Unlock your digital dreams. This is New Deep Dive.
Welcome to the Deep Dive. Today, we're tackling something truly cosmic.
You can say that. Our own star, the sun.
Exactly. We're going closer than ever before, really getting into the heart of our solar system.
And it's perfect timing, isn't it? With the latest from NASA's Parker Solar Probe.
Right. For decades, scientists have been trying to really get a handle on the sun's outer atmosphere, the corona, and the solar wind, too.
Which, isn't just academic. These things directly impact us. Satellites, power grids.
Absolutely. So the mission for this deep dive, to unpack these brand new, groundbreaking insights, Parker just sent back the closest images of the sun ever taken.
And it's crucial to emphasize these aren't just, spectacular visuals.
No way. They're critical pieces of the puzzle.
Mm-hmm.
They're actually reshaping how we understand space weather and, like you said, how it affects us right here on Earth.
It's about seeing the source of space weather.
So get ready. We're going to explore some really cutting-edge science, dig into these sources, and find those aha moments.
What's really amazing here is how these images aren't, they're not just pictures. They fundamentally push forward our understanding of the sun's dynamics.
How so?
Well, Parker's solar probe is giving us this unprecedented, really closed-up view of the outer corona and where the solar wind gets going.
Which is vital for, better forecasts.
Exactly. Improving space weather forecasts.
Yeah.
And ultimately, that helps safeguard our technology. It's quite practical, really.
Indeed. And it's not just what it's seeing, but how it's doing it. That's incredible, too.
The engineering is something else.
Think about the scale here. December 24th, 2024, Parker Solar Probe breaks a record. Gets within, only 3.8 million miles of the sun's surface.
That is incredibly close. Just think about that distance.
And during this flyby, it's got this special camera, the wide-field imager, Wesper MEST. It's designed specifically to see the faint corona, the solar wind, right up against the sun's glare.
Which is usually completely overwhelming visually.
Right. And it wasn't just surviving there. It was capturing historic footage while moving at, get this, 692,000 kilometers per hour.
The fastest object humans have ever sent anywhere.
And during temperatures around 980 degrees Celsius, almost 1,000 degrees, all while gathering data inside that superheated atmosphere.
Nikki Fox from NASA put it really well.
Oh, yeah. What did she say?
She said the probe once again transferred us to the dynamic atmosphere of our closest star. We see where space weather threats to Earth begin with our own eyes. Not just with models.
With our own eyes. That's the key difference, isn't it? Seeing it directly.
It's a huge leap for solar physics. Relying just on models, well, it has its limits. Seeing it happen, that changes the game.
So what specific things are we seeing in these new images?
Well, these newly published images, they've captured several key things that were, let's say, tricky to observe before. For instance, the probe documented these things called switchbacks in the solar wind.
Switchbacks? What are those exactly?
When like abrupt zigzagging changes in the magnetic field. Sharp turns. And scientists have now definitively linked them, seen the connection to these funnel-shaped magnetic structures that start right on the sun's surface.
Wow. So it's not just a theory anymore. They saw the link.
A direct observation. It helps us basically rewrite the physics of how these powerful solar wind disturbances get going.
So these switchbacks, like sharp hairpin turns in the magnetic field lines guiding the solar wind, almost like the wind ties itself in knots for a second.
It's a decent analogy, yeah, before straightening out again.
And seeing that direct connection to structures on the sun, what does that tell us about how the solar wind speeds up? Does it change our old ideas?
Oh, it absolutely refines them. For years, the exact mechanisms, pushing the solar wind were a bit mysterious.
Right.
Observing these switchbacks coming right out of those magnetic funnels, it suggests a really powerful localized driver for the acceleration.
So not necessarily a uniform push everywhere.
Probably not. It points to these specific regions being incredibly important. It's a key piece of the puzzle.
Okay, so localized drivers. What else?
Well, beyond those dramatic magnetic kinks, the recordings also show something called the heliospheric current sheet.
Right, I've heard of that. That's the big one, isn't it?
It is. It's this huge, undulating surface stretching way out. It's essentially the dividing line, where the sun's main magnetic field flips direction. Think north to south.
Kind of like a magnetic equator for the whole solar system.
Exactly. And directly observing that helps us map the solar wind's bigger global structure, something we previously could only infer, really.
That is fascinating. A true magnetic boundary across the whole system. Okay, so this brings up a really important point. how does all this detail help keep us safe?
That's the crucial connection.
Scientists also saw coronal mass ejections, CMEs, actually colliding. Angeles Vorlidas, one of the WHISPER scientists, mentioned seeing how CMEs literally overlap.
Yes, that's another major finding in these images.
What do we learn from seeing them merge like that? How does that help us prepare for, when they head towards Earth?
Observing these CMEs colliding gives us critical data. We can see how these powerful clouds of plasma combine and evolve as they travel through the inner solar system.
Before they reach us.
Precisely. Before, we mostly just saw the aftermath, maybe inferred a collision happened. Now we're witnessing the interaction itself.
And why is understanding that interaction so vital?
Because CMEs, when they hit Earth's magnetic field, can cause major disruptions. Satellites, GPS, power grids, communications, they're all vulnerable.
Geomagnetic storms.
Exactly. So knowing how CMEs combine, how their magnetic fields might merge or interact, it allows for much more accurate predictions.
Predictions of?
Their arrival time, their trajectory, and crucially, their potential strength, their combined magnetic force.
Which gives us more warning.
More lead time, yeah. More time to protect critical infrastructure, put satellites in safe mode, things like that.
So this isn't just abstract science at all. It's directly about protecting our technological way of life.
Very much so.
The Parker Solar Probe, it launched back in 2018, right?
That's right.
And it's already done 24 orbits around the sun, using Venus's gravity to sort of slingshot itself closer each time.
Those Venus flybys are key to tightening the orbit, getting closer and closer to the sun.
But this incredible mission, it's not winding down, is it? What's coming up next?
Not at all.
Yeah.
It's really just getting into its prime observing phase. The probe will keep making these close flybys, about 3 times a year.
3 times a year. For how long?
Well, the mission is currently planned to last for another 10 to 15 years.
Wow, another decade or more of this data.
Exactly. And the data it's gathering is just invaluable. It's helping scientists dramatically improve those space weather predictions we talked about.
Nikki Fox again?
Yeah, she reiterated, these new data will allow us to significantly improve our space weather forecasts to keep our astronauts safe and protect our technology here on Earth and throughout the solar system.
Astronaut safety too, right? That's crucial as we venture further out.
Absolutely. This long-term data collection is fundamental for our future in space and just as importantly right here on Earth.
What an incredible deep dive this has been, exploring the Parker Solar Probe's journey. Really amazing stuff.
It really is groundbreaking work.
From those record-breaking images back on December 24th, 2024, to really getting grips with things like switchbacks and seeing CMEs actually collide.
It brings it home, doesn't it?
It absolutely reveals that critical, immediate link between what the sun is doing, its dynamic activity, and our daily lives here, safeguarding everything from communication networks to the power grid.
And like we said, this journey is far from over.
Right. Another 10, 15 years of close passes.
Close flybys about 3 times a year, continuing to gather this unprecedented data.
So that leads to a really interesting thought to leave everyone with.
Okay.
Well, given that these images, this data we've talked about, were really just the beginning of Parker's extended mission, just the start of truly understanding our star up close.
Right, we're just scratching the surface in some ways.
What other, maybe more profound connections between the sun's incredibly dynamic atmosphere and the intricate balance of, life and technology here on Earth might we still uncover?
That's the big question, isn't it? This probe, it isn't just exploring space for the sake of exploration.
No, it feels much more direct.
It's quite literally helping safeguard our future, which really makes you wonder, how much more do we need to learn to truly live in harmony with this incredibly powerful star we orbit, our home star?